Greetings from Pahasapa, the Black Hills, where the Lakota people come to pray for the state of the world, and maybe they ought to pray for the state of this program as it attempts to copy CW. This is Hamscope 1.56, listening to W1AW at their transmission, which they claim to be 20 words a minute. That's this program over here on the right is Hamscope. And over here on the left is Digipan, which I have set to show a waterfall display. Notice the frequency on the horizontal axis going from 0 here up to about 3300 hertz here, and this display going from 100 hertz here up to about 2756 hertz here. Let's give this thing a chance to copy. This is 20 words a minute. Well, obviously it's not having much luck. I can copy that just fine in my head. Can you? I remember when I took my extra class license back in 1973 at the test, they made us write down a solid minute of code at this speed. But you can hear it just fine. I mean, even if you can't actually follow it in your head, you should be able to tell that the human ear should be able to hear this just fine. But alas, the computer can't seem to manage it. Now, it could a little while ago, and maybe if I narrow down the receiver passband, it'll have a better shot at it. A little less noise, a little more signal. Better signal-to-noise ratio, I should say. It's having a lot better luck. Now, this is the same signal strength, but a narrower passband, 100 hertz instead of 500 hertz, which it was before. Does this prove that the signal-to-noise ratio and the intelligibility improve with narrowband signals as the passband gets narrower? Does it prove it or not? Back to the 500 hertz filter. Let's see how it does there. Well, I have no trouble copying that in my head, but the computer can't seem to do it. 500 hertz wide filter. Let's go back to 100 hertz again. Centered, of course. Now we're at 100 hertz, centered on the signal, and that's what this spectrum and waterfall display can help me do. Now, I believe that this demonstrates quite clearly the machine has a lot easier time copying this signal through the 100 hertz filter than it does through the 500 hertz filter, and the only possible reason is that the signal-to-noise ratio through the 100 hertz filter is better. The signal is the same strength in either case, but the noise through the 100 hertz filter is only 1/5. The noise through the 500 hertz filter, that only stands to reason. And yet, when I worked at this station that you're listening to, W1AW in Newington, Connecticut, when I worked here, let's see, I think they're going to go to 15 words a minute now. When I worked at that station, W1AW, I met an engineer who came in there, and he said that narrowing the bandwidth in a narrowband signal like this does not improve the signal-to-noise ratio, and I insisted that it does. Well, he pulled rank on me because he had a degree in engineering and I did not. And he said that because he had that degree in engineering, therefore he was correct and I was wrong. Well, I don't know. Maybe he was correct and I was wrong. But this computer agrees with me, I think. And computers are always right. Well, they're always almost right. Let's go back to the 500 hertz filter. Well, I think that'll about do it for this demonstration. What exactly am I trying to prove with this? I mean, that's a good question. Great Images in NASA is where I got this wallpaper. Jupiter, obviously, and a couple of its moons. There's one. You can see some of that. You can see all of that moon, and you can see some of this one over here, and I don't know which moons they are. I haven't memorized that. I don't remember which one is which. Jupiter has an awful lot of moons, though. Stan Gibilisco, W1GV, Whiskey 1 Golf Victor, demonstrating digipan and ham scope, copying CW after a fashion, and proving that the signal-to-noise ratio of a narrowband signal gets better when you narrow the bandwidth so that less noise competes with the signal. I rest my case. Self-taught hobby electronics guru at your service. Until next time, so long.